Okay, this video is going to do two more examples, example 5 and 6. We have 8 in total. Each example is meant to show you some other new strategy. So we look at this one here, 1 plus sine x times 1 minus sine x, and it equals cos squared x. So we haven't seen one like this, or at least not this year. You might have seen it last year. So just my goal today is, again, show you more strategies, and the more strategy you have, the more things you can try in each question. Not everything's going to work, but sometimes it will. So one of those strategies, list of strategies that I told you about, was right here. Remember your algebra rules when rearranging. Okay, so many of the algebra rules we do with just plain old x's behave the same for sine x or cos x. We saw it in the last example. We had x squared divided by x is just x. So same thing here. Some of these rules will still work. So if I look at this, I see 1 plus sine x and 1 minus sine x. Well, if these were just x's, I would do rainbow. So I can do rainbow for this. So the algebra rules are still the same. So I'm going to do rainbow. So 1 times 1 is 1. 1 times negative sine is negative sine x. Sine x times 1 is sine x. And the last one is a sine times the sine is sine squared. And it's a positive times the negative, so it's negative sine squared x. And algebra rules, if I have like terms, opposite signs, there's a negative sine x and a positive sine x. Well, if this was just negative x and plus x, they would cancel. Well, negative sine x and positive sine x, and those disappear. So again, this could be an example of where you would go too far and try and write down your next step. Just cancel it out in one line, write down 1 minus sine squared x, but I'm sure a lot of you are saying, hey, this is like the 5th or 6th time I've seen this. 1 minus sine squared x is cos squared x. Don't try and jump too many steps. Okay, a lot of people want to jump from here straight to here. They cancel these out and they go, oh yeah, 1 minus sine squared, and then they just write down cos squared. Do the canceling in one step, write this line down here, then write down cos squared x. It makes it for an easier explanation to follow. Pretend you're talking to someone who's having trouble with this, and you want to make sure you show every step. So the more that you skip, the less information I have. And I have left side equals right side. One thing, I'll finish off left side equals right side, and it is proven. Again, this is a great opportunity to say that maybe your answer is a little bit different than mine. So for example, some people may have gone off and said, hey, look, I only have sines on the left side, so I'm going to change the right side to a sine. Change this to 1 sine squared x. So they might have done that, and that's totally fine. If you do that, then you would stop at this line, because that's where they're equal. And that'd be fine. That'd be a totally legitimate solution. You changed a little bit on the left side, a little bit on the right side. Now they're equal, done. What you don't want to do is do both of these steps. So let's say you wrote this down. Okay, no problem. And then you're going around and you get to this. And then you go, hey, that equals cos. Well, that's true. But now if you look at the bottom lines, just look at the bottom line. There's a cos squared x, and there's a 1 minus sine squared x. Those are not left side equals right side. I know that they are, but you can't have your bottom line look different than your bottom line on the right. So you got to decide, where is it I'm going to stop? So maybe I don't go any further, and I just stop here. Now it's left side equals right side. Or maybe I come along and say, oh, I didn't need to do that. I'll get rid of this. Now the left side equals the right side. Okay? All right, here's 6. Again, we're going to look different.
girls' hockey team is excused now for their hockey game in Picton.
All right, let's see how this goes. Okay, first thing I'm going to do is show you something that's wrong. Remember here, we got sine squared equals 1 minus cos squared, and cos squared equals 1 minus sine squared. In order to do the rearranging, you have to have sine squared and cos squared. You cannot do this. You can't do sine theta plus cos theta equals 1. That's not true. It has to be sine squared and cos squared. Same thing here. Oops. See this? 1 minus cos. Oops. 1 minus cos. That is not cos squared. So you cannot change this to sine x. Okay, that's wrong. If this was squared, then you could change it to sine squared x. But it's not. Okay, so just being very careful on that, make sure you don't make that mistake. So then I say, well, I don't know what I'm going to do. Again, I look to the other side for inspiration. I notice that on this side, I've got no sines. Right, I've just got a cos. So I'm going to look over here and see that I have a sine. Can I do something to that? Well, sure. I know that sine squared is equal to 1 minus cos squared. So it's got that squared part in it. So that part's okay. Bottom, not so much. Next common mistake I see people do is trying to simplify here. They try and simplify this and this. I can't do it because they're attached with a minus, right? Remember that. We've had lots of examples of that. So I'm at this stage, I gotta figure something out. Well, it's starting to look more like this side, but it's not exactly. Now I'm gonna draw in a new strategy. If I think back to the last question, I used some algebra rule of rainbow. What's the opposite of rainbow? Factoring. So could I factor this? This is actually difference of squares. I've got a perfect square in 1 and a perfect square in cos squared. So this goes backwards and factors into 1 plus cos, 1 minus cos. Okay. Again, this is the thinking in my head. That's a difference of squares. Pretend it's an x squared. Factor that. Well, square root of the 1, square root of x. Put a plus between one and a minus between the other. That's difference of squares. So it's just not an x, it's a cos x. Cos squared. All right, so that's the top. Of course, the bottom stays the same as 1 minus cos x. I'm just going to tidy up my work here, make sure my equal signs are in the right spot. And now, I see I've got this factor on the bottom, the exact factor on the top, they will cancel. And I'm left with 1 plus cos x, and that is the right-hand side, so therefore left side equals right side, and it is proven. So, again, in these two examples in this video, I've showed you two different things. What you can do in doing a rainbow, that operation, and recognizing that you can factor. Those are both strategies that work.